My dear friends, welcome to SEKAR classes on applied data science with Python. This is lecture number 141. In this lecture, I will continue my discussion on confidence intervals. Just recall this particular diagram. We have spent a lot of time on this diagram. I completed this part. Which part? This part. In this lecture, we will try to understand estimation of population proportion and estimation of population variance with the help of sample proportion and sample variance. First, we will try to understand simple notation here. What is my capital P? You must understand this capital P must be a population proportion from here onwards. This P hat, I can say small p hat, this can be treated as sample proportion. This sigma P, sigma means what? Population standard deviation. Here capital P indicates population. Sigma means standard deviation. Whose standard deviation? It is a standard deviation of population. How can I calculate? Under root of capital P into 1 minus capital P by n. What is my capital P? My capital P is population proportion. In similar manner, I can calculate standard deviation. Which standard deviation? I can write SP cap. P cap means sample proportion standard deviation. Just it is under root of P hat. P hat means sample proportion. P hat into 1 minus P hat by n. You must take under root of this particular quantity. This can be treated as sample proportion standard deviation. This can be treated as population proportion standard deviation. This formula is important formula. This formula says it's a confidence interval. Is it not confidence interval? Yes, it's a confidence interval. Whose confidence interval? Population proportions confidence interval. This capital P indicates population proportion. Finding the population proportion with the help of sample proportion, isn't it? What is sample proportion? P hat. Confidence interval for the population proportion, isn't it? An interval estimate for the population proportion capital P can be calculated by adding an allowance for uncertainty to the sample proportion. What is that uncertainty? This is uncertainty, isn't it? This is uncertainty. You are adding and subtracting uncertainty, isn't it? For uncertainty to whom? To sample proportion. This for small p. This is a sample point, I can say. That allowance is nothing but standard error. This is standard error. Standard deviation means I can say it's a standard error. This is standard error. I can say this is SP cap. Is it not SP cap? Yes, it's an SP cap. I can say this. This entire portion can be treated as LL. This entire portion I can treat as UL. LL means lower limit and upper limit, as it has whose lower limit and whose upper limit? They are lower limit and upper limit of our capital P, that is population proportion. With the help of sampling proportion, we are able to predict lower limit and upper limit of population proportion. There is a condition. This condition, just try to have an idea on this condition. NPQ, here capital P plus capital Q equal to 1. NPQ or NP into 1 minus P is greater than 5. I will discuss this concept while discussing problems. As I told you, this small p cap is a sample proportion and N is the sample size. Z alpha by 2 value I already discussed in previous lectures. What is that Z alpha by 2 value, isn't it? Let me discuss one simple problem on this one. Just see, a random sample of 100 people. What is my sample size? My sample size n equal to 100 people. Show that 25 are left-handed. Out of 100, how many people are left-handed? 25. What is my p cap? My p cap, my sample size 25 by 100 means your sample proportion, a sample of 100 people, of 100, 25 are left-handed. Therefore, my sample proportion is 25 by 100. Now, what I have to do? Form a 95% confidence interval. 95% confidence interval means what is my confidence level? 1 minus alpha, isn't it? Yes. What is? How can I find this particular this one? My how can I say confidence interval? This is the formula. What is my formula? Just say this one. This is simple formula. As I told you, we know what is p cap. At Z alpha by 2, at 95%, in previous lectures I discussed Z alpha by 2 value at 95% interval, 95% confidence is 1.96. Just I am substituting these values. Just I am substituting, nothing more than that. What does it mean? Your population proportion is in between 0.1651 and 0.3349. Means we are 95% confident. What does it mean? We are 95% confident that the true percentage of left-handers in the population between 16.51% and 33.49%. Isn't it? That's what it says. Although the interval from 0.165 to 0.3349 may or may not contain true population, isn't it? What does it mean? A sample of, may or may not contain 95% of interval formed. This what is the interval here? 95% confident interval, isn't it? I can say like this: if we repeat this 100 times, let me assume this is repeated 100 times. If you repeat this 100 times, 95 times, out of 100 times, 95 times, your capital P is in between 0.165 and 0.3349. Only 5 times it is not in between 0.1651 and 0.3349. Isn't it? Yes. Now, I can say we completed, which portion we completed? Just this entire portion we completed. Means just now we discussed population proportion estimation. Last one of this lecture, that is population variance. How can I estimate population variance with the help of sample variance? This is the formula. This is the formula for what? For chi-square distribution, chi-square of n-1 degrees of freedom equal to, that is n-1 into s square by sigma square. What is my s square? S square is sample variance. This s square is, it is sample variance. It is sample variance. Whereas your sigma square is population variance. It is population variance. This one forms a chi-square distribution with n-1 degrees of freedom. This gives a confidence interval for chi-square distribution. I can say this is n-1. This is confidence interval for the population variance. What is sigma square? My sigma square is population variance. I am estimating population variance with the help of sample variance. S square is sample variance. This S square is sample variance. Anyway, we will try to understand this. This can be calculated. It is simple and straightforward. Just readjust this formula. Which formula? We already discussed this one. Chi-square of n-1 equal to n-1 into this we discussed in previous slide. n-1 into s square. S square means my sample variance and sigma square. Just cross multiply it and readjust. You will get this particular formula. What is this formula? This is formula for confidence interval. Whose confidence interval? Sigma square, population variance confidence interval, whose lower limit is this one, whose upper limit is this one. We will try to understand this with simple numerical example. Just see, we know that you are testing. Anyway, I will explain. Just let me just have an idea what is your formula, what it says. Your sample size is 17. Just remember, just understand, your sample size n equal to 17 and your sample standard deviation is 74 and you need 95% confidence interval. How can I calculate? As I told you, what is my formula? First we will try to calculate chi-square values. N is 17. Therefore, n minus 1 degrees of freedom, 17 minus 1, 16 degrees of freedom. I already discussed what is degrees of freedom. He says that what is your confidence interval? Your confidence level, I must say confidence level is 95%. That is 0.95. That is 0.95. Your confidence level is 1 minus alpha equal to 0.95. That is 1 minus 0.95 is equal to alpha. My alpha is 0.05, isn't it? This is chi-square of n minus 1 alpha by 2, 16 comma 0.025. How will I get this value? Just go to chi-square distribution table. On top of the row, you can find 0.025. And in this correspond here in column, you can find degrees of freedom, 16 degrees of freedom and 0.025. That intersecting value is 28.85. Isn't it? In similar manner, chi-square of n minus 1, 17 minus 1, 16. That is 1 minus alpha by 2 is 0.975. That is 16 degrees of freedom. You can find in on top of this part 0.975. Just find corresponding value. Just refer that chi-square table. Anybody can understand. An elementary student can understand. You can get these values. But what I need confidence interval. Therefore, let me substitute this in confidence interval. Just see, what is my confidence interval formula? This is my confidence interval formula. We already calculated these two quantities. Just it's a matter of substituting, nothing more than that. What is my n? 17 minus 1. What is my sample standard deviation? S is 74. In question it's given. Just S is 74. S square, that is 74 square. Just I am substituting my sample variance. Just if I substitute, I will get this one. How can I get this is I can say this is confidence interval for sigma square. Means it's a confidence interval for population variance. How can I get confidence interval for population standard deviation? Just you must take square root throughout this inequality. If I take square root, what happens? I will get 55.1 less than sigma less than, if I take square root, I will get 112.6. Just check it out, isn't it? I can say, converting to standard deviations, we are 95% confident. We are 95% confident that the population standard deviation, that is sigma, population standard deviation of CPU speed, it's a population standard deviation of central processing unit speed is in between 55.1 and 112.6 mHz. It is in between 55.1 and 112.6 megahertz frequency. Yes, I will repeat, converting to standard deviation, we are 95% confident that the population standard deviation of central processing unit, that is CPU speed, is between 55.1 and 112.6 megahertz. Thank you very much. Just go through this lecture. It is simple and straightforward lecture. If you have any difficulty, just keep a comment. Thank you again.